So now let's look at positive feedback. So positive feedback amplifies change and is destabilizing. So if we look at our example here, this is an example of the relationship or positive feedback between increased global temperatures, permafrost melt, and increased levels of greenhouse gases in the atmosphere. So permafrost exists closer to the Arctic, so you could think about areas of northern Russia, as well as northern Canada. So in these areas, there's a zone of the ground that's permanently frozen throughout the entire year. And it stores water, but it also stores organic matter that's frozen. So the fear is that if that organic matter melts, then it'll start decomposing, and the decomposition of that organic matter will release carbon dioxide and methane into the atmosphere. And carbon dioxide and methane are considered greenhouse gases, so they're associated with increased temperature. So they feel that if the permafrost melts and this matter decomposes, then there will be increased greenhouse gases, which will thus increase the temperature even more. And then with a higher global temperature, then more of the permafrost will melt, releasing more carbon dioxide and methane into the atmosphere, and then increasing global temperatures even more. So this would be a positive feedback loop. So it's destabilizing. So we're saying that it could potentially cause global temperatures to continue to rise, as well as the permafrost to continue to melt, and for there to be an even greater level of carbon dioxide and methane released into the atmosphere. So not returning to an equilibrium, but continuously changing. So destabilizing. So this is just a review of those positive and negative feedback loops. There is a lot of fear that positive feedback loops will present a lot of challenges associated with global climate change, though there are also negative feedback loops associated with climate and weather as well. Right, so we're going to take a look at resilience. Resilience is the ability of an ecosystem to bounce back from a disturbance. If you think about a person who is resilient, you would think of a person who is resilient as someone who could easily recover from challenges, and the same is true for an ecosystem. So ecosystems do encounter disturbances, and some of them are natural and some of them are man-made. So there's a whole list of them here. A flood or fire, those might be naturally occurring. Windstorm could be naturally occurring. Insect population explosions could be naturally occurring, or could have um, some conditions created by man as well that would lead for that to happen, such as a release of a population of insects in an area. And then there's stuff that is definitely associated with human influence, like deforestation, fracking, and pesticides. So some disturbances can easily be overcome and others cannot. So we're thinking about the ability for an ecosystem to bounce back. There are some things that are so quick to recover, like the studies have been done on forest fires, and forest fires, if they are just ground fires, so they do not burn in the entire canopy of the forest, they can be really, really easy to overcome. So within a few years, you might not even know that that fire had occurred. On the other hand, there are big changes that can be hugely impactful for an ecosystem, and sometimes it's really, really challenging for the ecosystem to bounce back from that. So if we think about an area that has been totally exploited and mined, maybe the topsoil has been removed, that's going to be really hard to recover from, as well as some pollution. So some types of pollution are very, very hard to overcome, and sometimes changes that occur might cause the loss of ecosystem for some of the organisms, and if those ecosystems can't live there anymore, they might not return. So when we think about these situations in which an ecosystem no longer is resilient, so it no longer can bounce back, this is when we've achieved a tipping point. So a tipping point is like a point of no return. Once we get to that point, there is no longer any recovery. So this can be associated with positive feedback loops. So if an ecosystem is changing and changing and changing too much, it could potentially get to a point where it's never going to be able to fully recover again. So tipping points are a huge concern associated with global climate change. Some people are arguing now if we are already past the tipping point for climate change, or if we're quickly approaching that tipping point, because we're concerned that if we get to a certain point, the whole matter might be out of our control, and we'll be stuck in this positive feedback loop where we will no longer really be able to influence the increasing global temperatures anymore. So it's a huge concern that people have. But this is a term that you absolutely need to know. So it's called a tipping point. So this is the point after which recovery is no longer possible within an ecosystem. This tipping point can be tricky to identify. I think that, what they say, hindsight is 2020. So as we're moving into the future, we have to be really cognizant and just really thoughtful about what it is that we're doing, because we're not going to be totally sure when tipping points have been achieved. It really will only be afterwards that we'll see the error in our ways, if you will. So tipping points can be associated with the following, or people are very concerned about the impact of tipping points when it comes to ice melt, the loss of glaciers, and rainforest destruction, particularly the Amazonian rainforest, because it is the biggest rainforest on Earth. So I hope that that was not too upsetting. I hope you can think about your influence that you have on the natural environment, because we are trying to increase the resilience of an environment and reduce the likelihood that we will achieve these tipping points. All right, ladies and gentlemen, have a great weekend. I will see you Monday or Tuesday. Bye.